Well, let's do T versus V. And let's make this like that. So here is a vapor dome. And we can label these as Kelvin or degrees C and meters cubed per kilogram. And if I draw a line like this, what did I just draw there? Yep. What does that line represent, though? Phase changes. And that line is a constant pressure line. Okay. So on the left of this line, from here to the left, what do we call that line? Saturated liquid line. Yep. So anything to the left of that line, you are a liquid, compressed liquid. Anything in between, then, it's a mixture between liquid or a vapor. So this is only dealing with liquid and vapors. We're not dealing with anything solid. Yep. And then on the right of this line, which is called, what's this purple line now? Saturated vapor line. Anything to the right of that, you are a vapor or superheat or a gas. They're kind of all used interchangeable. Okay. This, what did we call this subscript on the left, on the saturated liquid line? V sub F. Thank you. On this side, V sub G. Those are important here in a minute. So V sub F is the specific volume on the saturated liquid line. V sub G, specific volume on saturated vapor line. And V sub Fg, which you see in your tables, is Vg minus Vf. And these values can be found on table A4 and A5. Okay, so sorry, this is for water, I guess. A4 and A5 in metric. Okay. English, I think it's table AE or A4E or something like that. So let's just do a quick example. So a rigid, I'm gonna leave this like that, I guess. Fix it. A rigid tank contains 100 kilograms of saturated liquid H2O at 75 degrees C. What we want to do is find the pressure and volume. All right. Keywords. What are some keywords?
Saturated liquid.
Yep. That means what?
No vapor.
Huh?
No vapor.
Okay, no vapor. Yep. But what about
Saturated liquid.
we're on the saturated liquid line. So anything we look up, we're going to find with subscript F. Okay? Yep. What else? A rigid tank means what? Really, the volume isn't going to change, okay? And if you're on the saturated liquid line, okay, then what's the pressure? It will be constant. Yep. So we're right here, right? So the pressure and temperature from this point to the right are all called what? Saturated temperatures and pressures. So anytime you're from here to the right to here, the temperature, if you notice, is a perfect horizontal line. That means it's the same. It's called the saturated temperature. And this, we already said, was one constant pressure line, so the pressure is constant. So anytime you're between, in the mixture here, you automatically know what your temperature and your pressures are, because it's the phase change. That's where it's changing phase. So you just go to the back of the book at that temperature and you can find it. Okay? So, P at temperature of 35 degrees C is really your saturated pressure. And I'm going to get to the tables here in a minute. But let's write these values down. 38.6 kilopascals. Yes. Why it's 38.6?
No, 35 degrees Celsius.
Oh, why did I write 35? 75. That was my mistake. Thank you. Don't ask me why I did that. I just completely zoned out. Must be. And VF is 0.001026. You like these sig figs? Actually, you got to keep these, because these have been experimentally found to be true. So you want to keep those and then round at the end. So let's just finish this, and then I'll go to the tables and we'll look these up to make sure you know how to look them up, okay? How do I find volume now? Multiply by mass, because what are the units? Meters cubed per kilogram. We have 100 kilograms. Mass times specific volume. Yep. That make sense? Okay. So I'll come back here, but let's get to the tables. See how good you are with tables. And when you do these problems, it would probably be good to write the tables down, because when you go back to look at the study for your test, you are going to be like, where did I get this? So what's the temperature? 75? So I can zoom right in here, right? So table A4, we go over to the left column, and this is your temperature. We're at 75 C, and boom, we automatically know our pressure, 38.6 kilopascals. Okay? Because we're on the saturated liquid line. Okay? And then right here is our VF, saturated vapor, 0.001026. Okay? Oh yeah, everything's here. Yeah. All right. Next page. Questions? Yes?
Can you give us a value when you what's on it?
You have to interpolate. Oh, this is where interpolation comes in. Yep. Yep. There is a long way, and there's a shortcut way. Whatever way you want to do it, it's up to you. Okay? In your homework, I want you to do it by hand. Okay? Don't plug the values in unless you make an Excel sheet or a MATLAB script. Then you can use that. Okay? If you physically made it and you print it and you staple in the back, perfectly fine. Because then you show me that you can do this. Okay? All right. Let's talk about enthalpy. So enthalpy is what they call H, and it's just a combination of internal energy plus pressure over rho. That's it. They just combine these two. Why? It's just a shortcut. Later in the second law, when we do it for an open system, we just replace U plus PV with H. Okay? If I tell you find HF, where's that located on?
The left side.
The left side, which is called
The liquid side.
the saturated liquid line. Yep. And then, oh, I thought it was something else. HG, blah, 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 and then same thing with HFG. HG minus HF. So we have specific volume. Actually, technically this is what? I forgot. Specific enthalpy, right? Because it's lowercase. Then you could also have entropy, which we're going to cover second half of the semester. Okay. All right. Now let's look in between the saturated lines. So saturated, liquid, vapor. And it's called a mixture. Sorry, does everyone have the black equations? So we're in between the two lines. You remember what we had to use, what variable? Last class when we talked about it. X or quality. Yep. Oh, that funny looking tail. It's called quality. The quality on the left is 0, and they typically use the quality on the right as 1. So it goes from 0 to 1. You want to find the total mass, MT. It's the mass of the liquid plus the mass of the vapor. Okay, mass is always conserved. So whatever leaves the liquid to go to vapor, that's the mass of the vapor. Okay. So.
And that's in closed system.
Closed system. Yes, good call. Yep, closed system. Yep. How do we find? Say we want to find this value right here, and let's call it V sub 1. So we're at state 1. We want to find a specific volume, and I don't know. Let's say the quality is 0.2. Tell me how you would do this. What would you do? First off, what do we know about that point right now?
Like temperature the same as like 0, like quality 1 and quality 0.
Wait, say that again?
Temperature is the same as quality of X.
Oh.
When quality 0 and quality 1.
Okay. So if we're right here, so we know the quality is 0.2. We already automatically know that we're at saturation temperatures and pressures, right? Because we're in this point. Okay? Yep. Good. Yes. Did I have that as a gas last time? Let's double check. So I don't remember always off my head. It was day 1, right? Right there. Fraction of vapor over liquid. Yep. Yep. Okay. That's day 2. So if I tell you, anytime I tell you the quality is between 0 and 1, anytime, then you know we're at saturation temperatures and we're at saturation pressures. We're doing a phase change. Okay. So that's the first thing. And we now know we can find, I'm just going to erase these. You already told me that that value on the left is VF, and this is VG. If we know these two numbers, and we're trying to find the value in the middle, what's that called?
Interpolation.
Interpolation. Okay?
Then
You don't have to interpolate, because if you look on your first cheat sheet, very bottom, they've already interpolated those equations for you. Okay? So at the very bottom, it gives you the equation. So let's just write 1. So say we wanted to find V1. It would be the quality times VG1 plus 1 minus the quality VF1. You see that? It's the last equation, the bottom right equation. So they've already done the interpolation equations for you, and you just plug it into that equation. And the same goes for enthalpy, internal energy, entropy, which is S, and specific volume. Okay? Does that make sense? So if I just say the quality is 0.2, can you do anything with this problem?
Yeah.
Not necessarily. You need what?
Temperature.
Or
Pressure.
pressure. You need two things to figure out where you are. You have to. Otherwise, you don't know. Okay. So you have to know. You either have to. I have to tell you the pressure, or I'll probably tell you the pressure, right? To have you look up what the temperature is. Okay. Just kind of give you. But that's the idea here. Okay.
You give us like VG or VF then? Or
I could give you VF. So I could give you quality, and I can give you VF, right? Because then you could look up at the tables where that VF matches, and then you already know, okay, that's the temperature and pressure. Yep. Yep. Or I could give you quality and VG. I could give you quality and pressure. I could give you quality and temperature. I could give you quality and enthalpy. Endless amounts. But you need two things to know where you are on the vapor dome. There is. You're pretty much going to draw one for every problem from here on out, because you got to know where you are in the states. But the first two are going to be kind of examples we're going to do later. I give you a table of random pressures and temperatures. You have to fill in the table by looking at the chart. Yep. Okay, so this is. Oh, go ahead. Do you have another question, Kevin? Or no? Okay. This is a saturated liquid. Let's look at the superheated vapor, or superheats, whatever. So over here to the right, and you want to use A6 for H2O, so for water. And the rules are this. And I'm going to draw two lines on here. Not quite the way I wanted to do it, but that's fine. Let me erase those. And this will probably be green. So in order to figure out, okay, where we are and how do we identify stuff, the first thing is the pressure will be lower than Psat at a given temperature. Okay, so let's look at these two lines I made. At a given temperature, what does that mean? What does it look like on a line if it's the same temperature? Horizontal line. So let's pick a horizontal line here. Okay, and let's go back here to day 1. You had this in your notes. So the higher pressure was the one up above, right? So let's go back to this. So this one has a higher pressure. So this is Psat right there where I did this circle, right? So at a given temperature, pressure is less than Psat. Okay, because say we're on this purple line. Okay, that pressure is lower than Psat. Okay, because that Psat's up above that. Does that make sense? Does everyone see that? Because this brown dotted up here, or this brown line, represents a higher pressure than the one we're at right now. So say we're at the purple one. If we pick this point right here, say we're right there, that pressure is lower than Psat based on these two lines we just made. Okay? So that's rule number 1. Rule number 2, the actual temperature is greater than Tsat at a given pressure. And you could do this by looking at the PV and doing these two lines again.
You said the temperature was lower than Tsat?
It's higher than Tsat. What about your specific volume? What's that higher than? Or VG? Yep. Yep. And that holds true for all of these, right? U, UG, etc. Oh, that's greater than. And we'll go through practice. We're going to go through practice problem. You're going to have homework problems to make sure. So these are the rules that help you identify. Okay, if we're at this pressure and we know the temperature, and we check to see what Psat is, and if it's less than it, then we know we're a superheat. Okay. If I give you specific volume in a temperature, and you look, and the specific volume is greater than Vg, you're a superheat. Okay. Okay. So those are the rules for superheats. So we've done vapors, we've done mixtures, and what's left? Compressed liquids. Okay. Number 1, P is greater than Psat. 2, T is less than Tsat. 3, V is less than VF, and that holds true for the rest of them. So to help you explain number one, let's do that together. I don't have it on here, but let's plot it. So you kind of know that's the vapor dome for TV. And I don't know, let's pick, we're on this red line here. These are at, at given temperature, at given pressure. I'll erase that, put that a little closer. And I don't know, let's draw another line here. And you said a horizontal line is constant temperature, so let's just draw, whoops. Let's do it right here, sure. No, I have to move that one, I believe, up. You have to put it here. So at a given temperature, right here, so let's just look at this. What's that look like? And would we say the top one has a higher pressure? So let's just pick, I don't know, 10 megapascals, and this one is 1 megapascal. All right, so instead of picking the red to be us, let's say we're on the blue line. So we're on this blue line, we're at 10 megapascals, we're on the left of this line. Say we're right here at this point. What's that pressure? So this whole blue line is the same pressure. So 10 megapascals. What's the saturation pressure at that temperature? It's at this line, this red, which is 1 megapascal. So the pressure is higher than Psat. Okay, does that make sense? Because Psat's in the middle here, and we're at that pressure there. Okay, so if you're stuck and it doesn't make sense, take a look at these graphs and how you plot them. Okay, we're on this blue line. We're right here. Our pressure is 10 megapascal. If we draw a horizontal line, we can then plot another pressure line to figure out, okay, that's at a lower pressure. It could be 1, it could be anything lower than 10. I'm just kind of make up some numbers. But that's your saturation because it's inside here. So the pressure is going to be greater than Psat. All right, ready to do a practice problem now? All right. Okay, so let's make some grids. Start something new up here. And we got 1, 2, 3. And we got 1, 2, and then 1 more. 3. So these are to give you practice. So minus 12, 30, 60. This is temperature in degrees C. Then we have pressure in kilopascals. So 320, 550, 600. And finish plugging these in, and then I'll plug my computer in. This is specific volume. And this is the phase description. All right, so here, this is refrigerant. Let's put that down here. So this is refrigerant. So some working fluid, 134A. Now, each case, what do I have? This is A, B, C, and D. They're not related, completely different. But I want to practice, like, if you know your temperature and your pressure on A, tell me what the specific volume is in your phase, okay? So which one would you want to do first? Case A, you want to start with A? Okay, let's do A. Okay, I did not do A first. Oh, I did it right there. That's all right. We'll start with A. So, what I want you to do is, with these homeworks, is just draw a small vapor dome, label it, draw it, and then on the right, put your temperatures down that we have on the table or whatever. And what do we need to do? What do we need to do? What's that? Go in the book. What are we going to look up? Say that again. No, you're right.
Yeah.
Just keep going. For
We're find out refrigerant.
yeah, we have to look up refrigerant, but okay. So we're going to go to -12. What are we going to check? Pressures. Yep, I heard pressure. Sorry, Tyler. I heard pressure. What pressure, though? Saturation, right? So, table A-11. We find that the Psat, and I'll go to the table. I'll go to the books. Is 185.37 kilopascals at T's -12 degrees C. So P is what compared to Sat? Higher. So where are we? What? Compressed liquid, right? I hope that's what I have in my notes, right? So we're somewhere over here. And let me finish this. So we now know the pressure, we know the specific volume. Oops, I wanted to do this. The specific volume, anytime you're compressed liquid, go ahead and use the F values. It doesn't change much. Okay? This is 0.00075 meters cubed per kilogram. So earlier this lecture, I just kind of random, okay, compressed liquid, what are the rules? Now you could apply those rules to figure out where you are, what the phase change, and the values. Looks like everyone has them. So let's just go to the table. So it's A11, right? Ooh. Here we go. Right here. So we're doing refrigerant 134. And what was the temperature? -12. So let me zoom right into this puppy. Right there, right? So we're down here. I'll go up a little bit. So minus 12, and the pressure is 185, the saturation pressure right here. Okay. Anytime you're a compressed liquid, it's fine to assume that the value for specific volume is VF. So this one, is this one I wrote down? Yep, I rounded. Okay. Make sense? Anytime it's compressed, yep, assume VF, yep. All right, next one. Which one do you want to do next? I think Tyler was hinting to go with C. Let's do C.
I don't see where to go.
Okay. Or C. Draw a quick vapor dome. And what do we have in C? We have the pressure, 550 kilopascals. We know we're saturated vapor. Okay. So, what do we do next?
We'll look up. Yeah. Medium height.
Yep, it's VG, right?
Yeah.
So we're where on this line?
On the right side.
On the right side somewhere, right here. So the first thing is, if we're on a line, either right or left, what's your pressures? Constant, and they're saturated, right? So P, just for reference, is Psat, and T equals Tsat. And V is VG. And I'll give you this value, and we'll go to the tables. And T is 18.73 degrees C. Why are we doing this? Because this is the first step when we start dealing with the first law in the next chapter in open systems. So we look at a overall like refrigerant cycle. It goes through all these changes. You got to know what temperatures and pressures you're at because you can relate those back to work and power. Okay, so this is the first step in understanding how to calculate that stuff. Anytime you're on this line or that line or in between, saturation temperatures, saturation pressures, because it's a phase change. Yep. But what does it mean we're on this side? We're all vapor. On the left, we're all liquid still. Yep. So let's just go to the tables and then we'll end it here. It was 550. So I didn't write this down, but you want to write it down. Use A12. Why don't we use A11? You could, but you'd have to interpolate, right? Because the pressures are here, not the temperatures. You want the pressures on the left because that's what's given, which is the next section here, A12. Pressure was 550. 550, and then that's the temperature next column, 18.73. And what was it? VG, 0.0374, which is so right along this. So this is pressure, temperature, VF, VG. Okay? All right.